Hello, what's up, everyone? This is the Spoke Bharata once again for my second web series on quantum mechanics. But this time I will be talking about Big Bang, and this is in continuation with yesterday's session on quantum mechanics. I will not try to make it long. Hopefully, 30 minutes is enough. And again, as I said, this is not a learning session. This is just a consolidation uh, of my knowledge and understanding, which I have gathered over years, and just trying to collate it in this session, catalog it in this session. And as usual, there will be few criticisms, there will be mistakes. So please feel free, put it on my comments. I will try to correct it. The presentations are not at all perfect. This has been made in real hurry. So let's, without wasting, let's see like if I can, what we covered yesterday. We covered yesterday about what is quantum mechanics. These are the subatomic particles that talks about the reality at the subatomic particles, at the electrons, photons, at that level. Uh, and the two important phenomena which occurs at that level, as I said, are superposition and entanglement, and this is described through a quantum wave function behavior denoted by psi, and we explained yesterday how do we, what are the mathematical operators, how do we describe momentum, how do we describe positions as an operator for the psi functions. How do we also spoke about superposition being the ability of a particle to remain in multiple states. For example, in this state it can be either left or right, and only when observation is made, it collapses, the wave function collapses, and then only we get one of these states. So this is again, these are the various operators we spoke. I will not go into much detail. It is also described by bra and cat bracket in short notation for bracket. Uh, this is what we describe the probability. For example, a wave function, a electron can have a spin up and down, and it can be represented, for example, as a wave function which has a root 3 two times of a up possibility and a half time of down possibility. And when we do the square root with the square, we get the probability of that state when the wave function collapses. So individually, it can be either of the states, and the total of the state we call it as Hilbert space. In the Hilbert space, we define these probabilities when it collapses. So these are also can be expressed as a vector notation, which are orthogonal products. And then we also spoke about entanglement, which is another behavior which Einstein called as spooky actions, which happens over when an state of an electron is taken far off. The quantum entangle, the property of the wave never changes, wave function never changes. So if you have an electron in up direction, and if you change it to another in the down direction, it impacts the behavior at the other state. So that's why the collective, so the probability of finding a particle B in certain state changes after we interact with particle A. So we describe the, for example, if we have A and B, then the total wave function can be described as up A, up B plus up A, down B, and similar all possible states. And then also we spoke about Heisenberg's uncertainty principle. The It describes about the uncertainty in position, uncertainty in momentum. Uh, uh, we also have a similar corollary. We will talk about energy time, which are again conjugate behaviors of the uncertainty principle. Now, we also spoke about Schrodinger, which is the energy state, the way to calculate the Hamiltonian operator as a time derivative of a wave function, I being the complex number, h being the Planck's constant. Mm, Now let's cumulative. Yeah. So this was in brief, and we also spoke about consciousness, which I will skip. Otherwise, I will not be able to start the Big Bang, and then we talk about the double slit experiment. So this is now let's talk about what is the what is the correlation between Big Bang and quantum mechanics. Why I have taken as a continuity. The reason is so basically, Big Bang can be explained at the inflation point, at the inflection point, at the inflation point when there was nothing. Mm, the Big Bang is the result of this quantum behavior called quantum gravity, which will talk uh, how from nothingness we can still have energy due to something called due to something called, we call it like Heisenberg uncertainty principle. So at whenever the certainty in time decreases, then we have all of a sudden energy virtual particles popping up, and the energy actually acquires this suddenly the energy quantum tunneling happens. Suddenly the energy can acquire to an higher level energy, and that is how from nothingness we can always have an energy state, and that is where the Big Bang takes place. Let's go. We, as I said, this is a web series. So this series, I will be talking about what exactly, what are the stages in the Big Bang. This has many facets. I mean, for example, it will we will need to talk about the standard model of describing the particles. And what is standard model? Model is defined by the bosons, force carrying exchange particle, and the particle fermions. And in both, if I could have, we will talk later on. I don't want to, confuse everyone with this. All I wanted to keep it simple is that there are particles which are described by the standard models. All the quarks, the mesons, the leptons that we find, including the force-carrying particles, Higgs boson, are all described by standard model. Maybe in the next web series, we will talk in detail about the standard model along with the general theory of relativity. But for this, I would just keep it simple. So, what happens at the Planck's at the time zero? At the time, very time zero, uh, we don't exactly know. Uh, that is a trillionth of a second. We exactly don't know. We know the behavior only at 10 to the power minus 36. So remember time zero. If some many people ask what is the behavior. So at time zero, nothing is known, and it reminds me of Nasik the Suktam, and let's this is the Suktam actually, which talks about that there was no existence or non-existence at that point of time. There was no atmosphere or heaven above. There was who covered himself, who was the master of the wave, who was in dense and very deep. No death nor immortality then. No night nor light existed. And at the end it says, therefore who knows the truth? We don't exactly know. This is where what we are talking before 10 to the power minus 36. We don't know actually. It cannot be known. It is so complex that it cannot be known. Therefore, who knows the truth, how it came, how this creation comes? Let me try to give it a shot to recite it. Om Nas Nasa Nasa Na Nasa Dasinas Nasa De Nasa Dasinada Sadasita Tadanima naseda rajo na vyoma paroyata kim avarivya kuha kasya sharamam ambhya kim asida asanam abhiram na mrutyarasida mrutyam na tarhi na ratyam ahna Sita Prakchet Atha ko Vedayata Babua Yam Vishro Shrita Yata Bubhuva. Let me try it again. Nasa sinna sada sita nasa sidrajo no vyamo paroyata kim abhariva kuhasya sarmam amba kimasida ahanam abhiran na mrutyorasasida mrutyam na tarhi na ratyam ahana asita prakchet atha ko vedayata babhuva iyam virusitra yata babhuva. So this is exactly Nasikdam Suktam. It is described. So, as I said, time zero, there was nothingness, and there was a quantum fluctuation because of which there was a quantum tunneling. So, tunneling is basically uh, uh, the property of a wave function to suddenly acquire energy. Uh, uh, to suddenly acquire energy, and it happens because there is a always there, when we say nothingness, actually there is nothing called nothingness, because it always space time always has virtual particles which pops up all the time at time when there is a time delta t is very less than these virtual particle all the time pops up. So at the very beginning 10 to the power minus 43, which we call as Planck's constant. So it was all these forces were unified. So these are the forces uh, which are a part of the standard model, described as standard model, and they were all unified because of quantum gravity. This is where the quantum gravity comes into picture, because we have quantum fluctuation out here, and we have also all these forces unified together: electromagnetic, weak nuclear, strong nuclear, and gravitational. So there is no matter out here, all are unified, and that's where we are talking about the unifying force, unified field theory, which talks about how can we unify these. And in the next phase at 10 to the power minus 36 seconds, which is called grand unification, suddenly the gravitational force separates out, and the temperature is 10 to the power 29 K. And then what we have is the three forces: electromagnetic, weak nuclear, and strong nuclear forces. Then next is we have the strong nuclear forces, which separates out. So basically now we have strong nuclear force. We have the presence of the forces responsible for the quarks, that separates out. So now we just have the electromagnetic and weak nuclear forces. These are called electroweak forces, and this is at the 10th of our minus 32 seconds. So next we have the inflationary epoch, where actually the Big Bang starts. Suddenly, as we said, because of quantum tunneling, it suddenly acquired from nothingness. It acquires suddenly an energy state, and from there it explodes uh, by 26 orders of magnitude. And like it's like going from the size of a molecule to an object that is tens of lights of years. So after that, it releases all these particle quarks, anti quarks, which is particle antiparticle, gluons, and all the particles. And from there, we have reached now at the quark epoch 10 to minus 12, where we have currently the four forces that we uh, know together. And then for the first time, we now have the Higgs boson field, which is part of the bosonic particles, bosonic nature. And then we started having masses. And then we started having the protons and neutrons, which because of the hadrons, which resulted which cool which are made of quarks. Then we got protons and neutrons, and then the leptons got created, which is the basic building blocks of electrons and anti-leptons. And then it formed, cooled enough, they formed, we had now baryons. So basically we see that slowly, and as it as universe uh, as it cooled, and as time passed, we suddenly have at the 10th or minus 10 seconds, now we are having particles actually. And we know that because of the asymmetry between matter and antimatter, we have the matters existing in the universe. So this expansion continues, and we all know that we have these from CMB, cosmic micro, this radiations we are having, and that is how we come to know. So again, it didn't stop there. The hydrogen and helium again collected to form cloud of gases, and then the general theory of relativity came into picture. We'll talk about it in the next session. So this is how the universe got structured. We have like 400,000 years past, and then the universe got a kind of structures. We call it the photon epoch. So and then the cooling took continued to take place. So basically, we just described with respect to standard model how the Big Bang occurred. Now let's talk about one of these. Uh, we always talk about the big bounce, but there is another big bang. But there is another theory called big bounce, along with cyclical cosmological theory given by Roger Penrose. So what does this big bounce talks about? It talks about uh, that at the whenever there is a the universe continue to expand and expand, and then it suddenly like it collapses. Because of the black holes, it will continue to collapse, and this collapse will again shrink the universe to the level at which we call it uh, a Planck's constant, beyond which it cannot be further shrinked. And that is where again it will explode. So once it has reached the minimum Planck volume, the additional energy will now be bounced off, and then again it will create a big bang. So this is the continuous annihilation and creation of the universe that is talking about. So with this, I think now it is almost 20 minutes. So 20-minute session. So glad that we were able to make it short. We will continue to make further progress in the series, web series 3, where we'll further talk about the universe. We'll further talk about the standard model, about general theory of relativity, the Hawkins theorem, and we'll keep on consolidating the the evolution of physics from general theory to string theory to quantum mechanics. Thank you for watching, and as usual, this is an ongoing session, so there will be continuous improvement. And please pass on the comments. I will definitely take care if there is anything needed to be improved. Thank you very much. Okay, Amit has joined. Hello, Amit. How are you doing? Amit, can you unmute yourself? Amit, are you there? I cannot hear him. I did not notice when he joined. Amit, yeah, I can see him unmute. Okay, we'll end the session. Thank you very much.